Hello everyone, welcome to Restaurant Revenue Prediction Regression project. First we import the necessary libraries, then after importing necessary libraries, we import our CSV file. df is equal to pd.read_csv and we give our CSV file path, and then we use df.head to print the, or you can say to display the first 5 rows of a data frame. Now we check null values. df dot is null dot sum to check if our data frame contains null value or not. So our data frame does not contain any null values. Now for a summary of data frame, we have df.info. So from that we get we have, you can say, 7 numeric columns and one object type column. That is, uh, we have to do we have to perform one encoding in one column. Although we do not have any null values, but still if we use df name number of customers dot fill na, if there is there and if you can send null values, we use dot fill na and we give the main value and we give in place is equal to true. So it will save in this data frame also, in this data frame. Now if as cuisine type is our categorical variable, so for filling these null values we used mode here. So df cuisine type dot fill na with df cuisine dot mode, and we give first value of our mode in place is equal to true. Now for detecting outliers, I defined a function. Here first we use our IQR method. IQR method means first we calculated the first quartile and then our third quartile. Then we defined our IQR, that is interquartile range, by giving Q3 minus Q1. Now we defined our lower bound. Lower bound is Q1 minus 1.5 times of IQR, and upper bound is equal to Q3 plus 1.5 times of IQR, and we created an empty list of outliers. Now we created we started a for loop in our, you can say, series or array. If our value is less than lower bound or upper than upper bound, then we append in this outliers list and we return outliers here. Now I created a new list with all numeric columns. So we have 7 numeric columns. I defined it here. Now we created a for loop on this for calculating, or you can say detecting outlier values. So here we run this and we get so in our you can say independent variables we do not have any outlier values, but in a dependent variable, that is a monthly revenue, we have five outliers. Now for handling outliers, I also created a function replace outliers. So if our value is less than lower bound, then we replace it by lower bound, and if our value is greater than upper bound, then we replace it by upper bound. Here's the function. Now, for handling outliers, I used different technique also, like using z-score. So first we calculated a z-score by stats.z-score for each, you can say, this time I calculated for TFO of monthly revenue column, but we can calculate it for, you can say, all columns, and then created a DF where Z score is less than 3. I performed in this function for loop. So for each column, we calculated first Z score, and where Z score is less than 3, we take only those rows of our DFs and we save it in our DF. Now we perform one hot encoding. So we convert our categorical values into numeric values. So our cuisine type is categorical value. So using pt dot get dummies, we do one hot encoding. So if we run this code, we will get our values in true and false. So for converting into 0 and 1, we do dot as type int. So we save it in df1. Now we concatenate this df1 with our original data frame. So we define pd dot concatenate df drop column. We dropped this column from our df, and then concatenate with our this df1 with x is equal to 1. Now we created correlation matrix to check what's the correlation between our you can say features and target variables. Now df.core for calculating all the correlation. Now we are visualizing our correlation matrix in a heat map. So use sns.heatmap df.core annotation is equal to true, and fmt, that is our format, will be dot 0f. So it will be in this format, like one decimal point. Our title will be correlation matrix and pid dot show. So we get our correlation matrix here. Now for calculating the correlation related to our target variable, we use df.correlation with uh, monthly revenue. We do absolute here to get the absolute value. So some values are here negative and some are positive. So we give absolute to absolute our value. Then we short our value in descending order by giving ascending is equal to false. Now we split our data frame into independent variables or dependent variables, or you can say target variables and features. So for features, we define x is equal to df dot drop monthly revenue by x is 1. Dependent variables will be y is equal to df of monthly revenue. Now we are splitting our data into training and test set by using train test split x comma y comma. Our test size will be 0.2 and random state. We can give any value here. We use random state for the reproducibility, so that we split our data in you can say different machine, we get the same results. So we are now we are scaling our data. So we are using standard scaling here. So in standard scaling, what we are doing, we are transforming our data so that our for each column our mean value will be 0 and standard deviation will be 1. Using x train underscore scaled is equal to scalar dot fit transform on x train. So we fit our train fit our you can say using fit our standard scalar using x train, and then we transform this x train and save it in x train scale. X underscore test dot underscore scaled is equal to scale dot transform x underscore test. Also, again, we are transforming for you can say x underscore scale for grid search saving. Now we are training our model. So I created a dictionary. Here I defined all the regression algorithms. Here I used linear regression, lasso, ridge, elastic net, decision tree regressor, SVR, this random forest regressor, ADA boost regressor, and gradient boosting regressor, and bagging regressor with all their hyperparameters. Now I created an empty list. Scores is equal to empty list. Results is equal to empty dictionary. For algo name mp in algo dot items. So for this we are using reg is equal to grid search CV model name, our model parameters, cross validation will be 5, and we are returning true train score is equal to true. So we will get the results of our each you can say training data. Reg dot we fit our model here. Now results. Now we are saving for each algorithm. We are saving our cross validation results. Now we are appending model name, best score, and best parameters in our scores list. So by running this, we get this scores. You can say scores list. Now we convert this into a data frame by pd.dataframe by giving scores and giving three columns name, model, best score, and best performance. So here we get for each model we have their best scores and with their best parameters. So by observing this, we can see we are getting best results in our lasso where alpha is equal to true and selection is equal to cyclic. Define residual plot, and we give here y test and y pred. For residuals I calculated for residuals y test minus y pred. Now we change here figure size, created a scatter plot where x is equal to y pred and y is equal to residual. Now created a line here, x label, y label, and title. Similarly, we created a function for prediction versus actual graph. So defined prediction actual graph where by variables y test and y pred, created defined figure size, created scatter plot, and we plot the value. Uh, we defined x label, y label, and titles. Now we created another evaluation function where we first we give the model y test and x underscore test underscore scared. So first we calculate the y pred by model dot pred x test scared. So then we calculate the root mean square value, mean absolute value, mean absolute error, R2 score, and then we give you can say plot of a residual plot and prediction prediction versus actual graph. Now as we get the best score from lasso model, so we trained each individual model using these hyperparameters. Here we trained lasso is equal to alpha is equal to true and selection is equal to cyclic, and we give our random state is equal to 42. Now we get around 67, you can say 0.6730 of R2 score. Here is our residual plot, and this is our prediction versus actual plot. Now we are discussing why we are selecting lasso regression. So first reason is the best performance. As we uh, tried grid search CV, we get the best results from the lasso model. Also, second point is this is L1 regularization. So it helps in reducing overfitting. And second point is it helps in feature selection. Now we are discussing what will be the future recommendation, or you can say recommendation for future improvements. So here we do not manipulated our you can say independent variables. So for each column we can perform transformation to convert this into a normal distribution curve, to in a convert this in a normal distributed data, so it will increase our lasso performance. Another thing is we can do feature engineering by creating new features based on the domain knowledge, like we can create interactions between variables like promotion and customer spending. And third will be bias variance trade-off. Monitor the bias variance trade-off by analyzing model error. Thank you for watching.